And let's start off with just a little mindfulness practice and then get rolling. And we've got lots of news today. Oh boy. So just take a minute for yourself. Close your eyes and tune in to your body and breath. Just being aware of what is happening right now for you. Notice if there's anything coloring your experience right now, like a mood or feeling. Just let that be. And give yourself permission to feel whatever it is you're feeling right now. Just take a minute to give yourself a hug inside, or picture someone that you love giving you that hug. It is going to be okay. Just come back, and guys, if I start crying, it's just going to be okay. I'm okay. I'm just feeling emotional today. So, but you know what always helps? Math. Math always helps. Everything. Have I told you that I'm working with an Iranian woman? Have I told you this story? Yeah. I sent her this article because she's so depressed. She's in just deepest, near suicidal. And I sent her this article. It was about math. Math can help your depression. Some of you might think, I don't believe that. Math is the cause of my depression. Well, if you don't have pressure, right? If we just do the math and we enjoy the rhythms and the problem solving, then we can find some peace in just not thinking about the shit that makes us feel bad. I think that's what it comes down to. So, news. Exam 2 next Monday. At 12:15 today, a review thing will open up on world class. So there'll be a world class announcement. There is a final web work that will help. So this web work, I think it's web work 7. This is practice for the exam. This isn't just, here's some more homework to do for the exam. This is getting ready for the exam. There's also going to be an exam review. So this is required. I think there's actually also an extra credit still floating around, right, on web work. Exam review web work is not for credit. This is optional. Optimal. Option. Oh, I did. Okay, it's just that I can't see my characters. It's just my handwriting is so bad I can't even read it. exam review. You will have no calculators, of course, but you know, an 8.5 by 11 sheet and a derivative sheet. So let's see here. So you get 2 sheets, one note sheet, whatever you want on that, and then one derivative sheet. If you don't have a nice derivative sheet, happy to get you one. I'll post one on WorldClad. Would you like that? Yeah? Okay, so I'll put one up that I think is pretty good. And the rest of this week, we've just got one new little thing today that's just a tweak on what we've already been doing, but we're gonna spend the whole week just getting even better at derivatives. So Wednesday, today and Wednesday, we're gonna be doing problems together. Friday's class is just come and review, you know, so this is like a prep day. It will be in person here. And I also have a practice exam that I'm gonna give you. So I've got an exam that's a lot like the exam that you will take. And I'm gonna give that to you, and what I would recommend is that you take it like it's an exam. But I'm not gonna give it to you early, because I want you to hold off. Because I want you to prep and then do this practice exam before Friday, and then come in and we can clear up whatever problems you might still be having. So I think probably Wednesday I'll give you the practice exam. Does that sound okay? Yeah, and it's literally a lot like what you're gonna have to do. Because I want you to smoke this exam. I really do. Is there any questions on this, friends? No? Okay, cool. Oh, yes, yeah.
What is WebWork 7 do?
Oh, that's a great question. This is due like 1 minute before the exam. So it's due at the last minute possible. Get done before then. That sounds like a good plan. We don't want that shit going on for you. Okay. Do y'all have any questions about anything? Probably you're stupefied like me to just be back in this room, so that's understandable. Yeah. All right, our last topic is implicit differentiation. I've got, I think, kind of a unique way of explaining this. I hope it works. We'll find out. We'll definitely practice it until it does work. But what we've been doing so far is explicit. So far, we've done explicit differentiation. And what that means is that I've got this expression, y equals f of x, and the relationship between input and output is clear. So the relationship between input x and output y is clear. It's just right in front of you. It's literally explicitly laid out as a formula. Input this here, do whatever f says, get your output. Implicit differentiation is when the x and y variables are intertwined in a way that it's not clear if x is 3, what y would be correspondingly. So implicit differentiation that word is differentiation. It almost looks French, like differentiation or something there at the end. You know what I'm saying. This, how about we say, in this, we have a situation like this. I've got some expression in x and y, and it's equal to 0. So the relationship between x and y is hidden inside this function. So what do I mean by that? E.g., let's give some examples. So x squared plus y squared minus 4 equals 0.
Infinite amount of solutions, technically, right?
Oh, say that again?
Isn't there an infinite amount of solutions?
There are. Yeah, exactly. Yeah. Yeah. Do you actually, does anyone know what the collection,
What's a circle?
yeah, do you know what the radius is?
2?
Woo, yeah, hell yeah. So let's take a look here. We know some implicit shit, good stuff. Thank you. So this thing right here, if you actually plotted out all the points, I mean, let's just be really naive for a minute and say we don't know anything about this. You would just have to, so to get a graph, you let x take on different values, so pick x values, and find the corresponding y. So you end up with an equation to solve. So for example like this, so say x equals 1. So if x equals 1, then I've got 1 squared plus y squared minus 4 equals 0. And then I solve this. This says y squared equals 3. So y equals plus or minus square root of 3. And then I come over to get a graph. And I see that when x is 1, I've actually got 2 different y values. I've got square root of 3 and negative square root of 3. And so you'd have to do this with a lot. So if you put this into a graphing app, you went to Desmos, and you said, give me the graph of x squared plus y squared minus 4 equals 0. This is what Desmos would do. It would pick a bunch of x values, solve the equation that results, and then plot those points. If you do this whole thing, just like Adrian said, we're going to end up with something that looks like this. So here's 2, here's negative 2. Let's see here, this is 2, negative 2. This is going to be pretty bad. You get a circle. My points look like shit now. There we go. But this is just x squared plus y squared equals 4. And that's a circle of radius 2. Centered at the origin. So I'm not going to expect you to understand how to graph these things. That's not what this is going to be about. But what I am going to ask you to do is I'm going to give you an implicit equation and ask you to do something like this. Find the equation of the tangent line at a point on this curve. So let's say if 1 square root of 3, what is the equation of the tangent line? So let's talk about how we could do this with just stuff we already know. One thing we could do is make that explicit. So one route is to make the relationship explicit. The relationship between, that's twixt, x and y, explicit. And so that means you're going to solve for y in terms of x, i.e. solve for y in terms of x, and then just do regular calculus. Then take the derivative. So here, let's just see what that would look like. So we've got x squared plus y squared minus 4 equals 0. So I get all the non-y stuff to the other side. Take square root. Got to put this plus or minus here. The plus is for the top half. The minus is for the bottom half of the circle. And then take the derivative of this. This would require chain rule. And you have to worry about the plus minus stuff. So chain rule required. Let's not. Because there's a much better way. The way I'm going to show you today is so beautiful and so much better than doing this. I just want you to realize you could do this.
Could you also have negative x squared, the root of negative x squared plus 2?
So I think you are saying something like, you can tell that that's probably not going to be right, Alex, just by knowing me and knowing what I'm saying. I think you're saying this.
Yeah.
And that is a
Well, would it not be-
foul thing.
Well, couldn't it be a plus b squared though in this instance, since 4 is a constant?
Say that again?
Because the square root of 4 is 2, right?
Uh-huh.
Couldn't it be a plus b squared in this instance because 4 is a constant? Is a variable?
Well, regardless of what these are, this just isn't true. Let me just prove this to you. So let's say, 4 minus 1 squared. Let's say x is 1. Okay, so then what is this? This is going to be square root of 3, right? Your route says, tell me what your route. So this would be square root of 4.
Yeah.
Is that true?
No.
So this is a thing people wish was true. It is not true. Only with a product can you do that. Got that? Then we can do that. I'm glad you asked that.
Okay.
Stop such things in their tracks. So, here's a better way to do this. And it kind of uses the chain rule, but in a super elegant way. So, better way. Treat y as if it were a function of x, as if it were y equals y of x. So assume that maybe somewhere down the line someone's done this game that we just did here. So notice here, y is a function of x here. Depends on x. We're going to assume that over here. So in other words, we've got x squared plus y of x squared minus 4 equals 0. Now I'm going to this is going to get complicated looking for a minute, but then we're going to go back and make it simple. I just want to show you why this is the case. Take the derivative. So take the derivative with respect to x, and just go through, term by term. What happens to x squared? 2x. 2x, beautiful. What happens to this?
2y of x.
Times. So we did the outside. What's the derivative of the inside? Yeah. So notice that was the chain rule that I did here. I treated the inside like it was a function, did the derivative of the outside, and then times the derivative of the inside. So this is just the chain rule here. And then 4 just goes to 0, and then 0 just goes to 0. So let's simplify this. And watch what I'm going to do here. I'm going to suppress the of x onto y. So in other words, I'm just going to keep it in my mind that that's y of x, but just write it like this: 2y, y prime equals 0. This is the actual explanation, and I'm going to show you a mnemonic way to do this. Solve for y prime. And we'll have our derivative formula. But it will depend on y and x. But that's the trade-off for not having it look like that mess over there. So when I do this, I'm going to move the 2x to the other side by subtracting. And I'm going to divide both sides by 2y. And then check this out. This is just negative x over y. Here is my implicit derivative. And so you just give me a point on that circle in its x and y coordinates, and I plug them in here, and I've got the slope. So this is the formula for the slope given any xy point on that circle. So let's finish this question. The question was, find the equation of the tangent line to this at 1 square root of 3. So let's just restate that. So find equation of tangent line to square root of 3. So we do this derivative thing first, so we know y prime, which is the slope. Don't forget that, it's been a long break. Don't forget, that's just the slope of the tangent, is this, and so that's negative 1 over square root of 3. Done. That's the slope of this line, right here. And so then, the equation of the line is going to be this good old slope-intercept form. So y equals negative 1 over square root of 3, x minus 1, plus square root of 3. There we go. Pretty slick. That looks pretty weird. It's got lots of roots in it. Not attractive. But man, this part is cake. So this is what we're going to practice today. And let me say, do this a whole different way. That's what's happening. What if you don't care what's happening and you just want to do it? And I know that there are folks of you who feel that way. And I can't blame you. You're not going to be a mathematician. Some of you hopefully will be, or could be, certainly. Most folks in here aren't going to be. So how do we do this if we're not going to be a mathematician? Find y prime using implicit differentiation. So let's have fun now. Oh, let's do something crazy. So this, it kind of looks like the circle equation. Circle equations look like this. It's the radius squared. R. Right. Adrian knew this. Probably could draw a better circle than I'm drawing right now too. But so that's a circle. What happens when you up the exponents? Well, what happens is this gets a little sharper. So this thing right here actually kind of looks like this. It's got 1, 1, minus 1, minus 1. It's almost a little rectangular, or yeah, kind of diamond shaped. It gets flatter. Here. And the higher that exponent goes, so if I had like x to the 40th plus y to the 40th equals 1, this would almost look like a diamond. Here, it would be really cool. But we just want the derivative formula. So how do I do this? You don't need to know this. You don't need to know that. Well, you should know that, but you don't need to. So take the derivative, left to right. So the plan is differentiate everything. Treat y as if it were x, but when you differentiate a y thing, tack on a y prime. So, but when you differentiate a y thing, multiply by y prime. That might even sound weird, but after we do it like 3 times, you're totally going to know what I'm saying. So I take that original equation and I differentiate through. So d dx, x to the 4th, I know how to do that, that's cake. Treat y to the 4th like it was x to the 4th. So it would go to 4y cubed, power rule. It's something to the 4th. Does this times y prime. Because I just differentiated a y thing, I do it just like with my normal calculus, but I tack on times y prime, and then this just goes to 0. Solve for y prime. and then solve for y prime. Now this might be the place where some of y'all have some troubles if your algebra skills are a little fuzzy at times. But look what we got here, 4y cubed, y prime equals negative 4x cubed. Divide through by that coefficient. Oops. And then these cancel, so y prime equals negative x cubed over y cubed. That's your implicit derivative. And now knowing any x and y points on this curve, if I give you the x and y points, you can find the tangent slope using that formula. Okay, let me stop and just see if there are any questions before we keep on cranking. Any questions? On this? No? Okay, let's have more fun, because this is fun. It's not just tiniest bit of fun that we can have. Find y prime. What is the graph of this? It's not a curiosity.
Is it a line?
It is not a line. No. In fact, yeah, it's not a line. But if I wrote it like this, would this help? Because that's the other. What's that?
Is it like natural kind of?
It's got that. It's asymptotic for sure. It's a hyperbola nestled in the first and third quadrant. So if you sketch this thing out, it looks like this. That's all the x and y points. So it kind of got that. I know what you're saying. Yeah. It's got some asymptotic behavior. So now look, we can find y prime real easy using the power rule. But let's not. Let's do it implicitly. So check this out. Read that expression in your head. Read it to yourself. How do you say it? What word occurs? Times, product rule. Because everything is a variable now. So this, I'm going to use the product rule. X times y. So it's going to be the derivative of the x times the y left alone, plus the x left alone, times the derivative of y, which would go to 1, and then I multiply by y prime. Derivative of 1 is 0. Solve for y prime. So look. So we get y prime equals negative y over x. Make sure you understand that. Let me just show you that we actually did accomplish the same thing. Because if you went explicit on this, this would say y equals x to the negative first. So y prime would be negative x to the negative second. How does this look like that? Well, if you keep in mind that y is 1 over x, that's the relationship that's hidden here. We get y prime equals negative 1 over x over x. That's exactly the same thing as that up there. So it all works out. Math is good. Treats us right. Never changes the rules on us. All right, my friends, your turn. Find y prime is the statement. Find y prime. I'm gonna run to the restroom. It's a perfect moment for me because I think this will take a little while. Where did this come? This didn't like come from me.
It was
did
on
it?
the floor, so
I wonder if
it's
it,
right there.
yeah, it's weird. It feels like, because I have one of these on my door. I'm wondering if it got like, well, couldn't hurt to have two on my door. I think that is mine. Pretty subpar.
Should write your name on the back of it.
Well, let me just wait to make sure first. Otherwise, I'll bring it back. Yeah, yeah.
Don't want anybody stealing your certification.
I don't. No. I think I'm the only one in our hallway with that certificate. That certification. Intense training of several hours. What rule do we need here? Hell yeah. So we go through derivative of x squared, 2x, leave the other part alone. Leave the x squared alone. Derivative of y cubed is 3y squared times y prime. Plus derivative of x, 1, equals 0. That's step 1. Now comes, yeah, oh yes, yeah, woo! That is making me happy. Oh shit, that's the best thing that's happened to me today. Thank you. Okay, so now we got to solve for y prime. Let me show you a general rule, because this can get hairy. Right now we only have one y prime, but here's the general plan to solve for y prime. When things get hairy, step 1 is get all y prime stuff to the left-hand side. So on LHS, left-hand side. So here you're going to have y prime stuff. And then x stuff to the right. All other stuff to the right. So here's x stuff, constants, maybe some y. No, let's just not say that, because there'll be x's and y's and numbers, just other stuff. But all the y prime stuff is over here. Step 2, this all has a times y prime, factor y prime out of the left-hand side. So what you're going to get is y prime and then stuff equals other stuff. And then finally divide by this stuff. I don't know that this could be more precise at all. That's the basic plan. So let's do that here. This is already on the left-hand side. I'm going to leave it there. So I'm going to rearrange it and pull a 3 in front. Move this stuff to the other side. And that's always going to be with subtraction or addition as well. So I would say at this stage right here, this is all subtraction and addition. There's nothing else that you will do here. Then the division will occur here. So here's the y prime. It's got all this is the stuff. So y prime equals this right-hand expression over 3x squared y squared. And I would just leave it like that. It's a lot less ugly than if we solve this thing for y and then take the derivative. Yes, sir?
And the final answer, that's like still not that bad to just work back through to actually solve for what y is?
Ooh,
Like,
so
if you're trying to take, or, never mind.
we could verify it kind of like I did if you wanted. Maybe that's not what you were thinking.
No, I was, yeah, no, I was just thinking incorrectly. I understand.
I'm glad you got yourself all straight. Yeah. Yes.
So from the top row of your equation to the bottom row, okay, I guess down here, you mix up your x and y's.
Did I?
So you changed the 3y squared to 3x squared.
Oh, I forgot.
No,
Did I?
on the left side. That's
Okay,
it.
what did I do here?
It
So,
says 3x squared where it should be 3y squared and then.
You like
X.
mixed
Oh.
up the flip-flopped them.
oh shit, okay, I did screw up some stuff. Okay, so let me slow down here.
Wait, does that matter?
Let me just check, let me go through. So 2x that, and then this x squared, so that's okay, right? Yeah?
So you just like rewrote it differently on
Oh,
the next one.
okay, got it. So let me go slower. Okay, so this is okay. So
You put the
You
3
did,
out
you
in front,
did.
'cause it's
did
more-
I? What the fuck am I doing?
Well, no, you pulled the 3 out to the front. 'cause
Isn't
it's
that just
multiplication.
nicer notation?
It's just
Yeah,
nicer notation.
that's okay.
Oh, okay.
Oh, that's okay. Okay, yeah, okay. Yeah, I'm just you can multiply in any order, and I like my numbers out in front, so that's okay. So I was okay. Okay. Good. Hey, what the hell? Let's just make sure everybody feels like I'm okay. I think that's right. Yeah. All right. Get lots of head nods. That makes me happy. Let's do more. Be careful. Let's just read it together. Sign of chain rule, x times y, product rule. Layers of building. You're going to want to use parentheses when you do the derivative of the inside part.
Are we? Isn't it all just division?
No, so you do the outside, so
Oh,
definitely that
shit.
times,
Shit.
times that though, yes, yeah, perfect. Okay, perfect, and then times, that's not, okay, times the derivative of the inside, that's where the parentheses are going to be.
Not just be.
You know, because read that inside as it's multiplication.
Yeah. It's the most.
Okay, so let's put parentheses, yeah, so what's the derivative of x? 1 times y plus, no plus, leave the x alone, that's the derivative of the y, 1, and then times y prime, because you just touched a y. Yeah, and close the parentheses, that's it equals 0. Now, there you go.
Now I just have to solve that.
Now you just have to solve that for y prime. Let's see how this should be times. Because, yeah, is that a times?
Yeah.
Oh, okay, gotcha. Oh, I see, then you, okay, I see what you did. Yeah, you, okay, sorry. What was I thinking? Well. you and I are so close. Oh, and then the right side goes to 0. That's,
Oh,
so that's,
right,
yeah,
yeah.
so that's the only. How's it going, Aries? Yes. So, yes, so this, I would put this all in, oh, so put this all in parentheses. There's like a big paren from there to there, because that's, this thing here is beautiful, but it's the derivative of your inside, and that whole thing. So you need a left parenthesis there, and then maybe there's, I don't know, there's a lot of parentheses here, so maybe there's one to match, maybe one more. And then, what's the derivative of 1?
Oh.
Perfect, yes, yes. Yeah, that's beautiful, that's it, and then just find your way home. check ourselves. Derivative of the outside is cosine, leave the inside alone, times the derivative of the entire inside. That's why I put these brackets here. Derivative of x is 1, leave the y alone, plus, because it's product rule, leave the x alone times the derivative of y, which is 1, and I just differentiated a y thing, so y prime equals derivative of 1, which is 0. Couple of things you could do here. If you wanted to make life easy, you could just divide both sides by cosine of xy. Kind of tosses it out. That's assuming it's not 0, which might be a dicey proposition. You see what I'm saying though? You could just like, this is times all that, so you could just go, kill it off. Or what a number of folks are doing is distributing. Let's just go that route. So that times that, plus that times that. Equals 0. And then you bring all the y prime stuff to the left. Well, it's already on the left. Bring this to the other side by subtraction, right? Only subtraction at this stage. Divide both sides by this to isolate the y prime. You'll see that those cosines could have been canceled earlier if you wanted. And you could just get that. So it turns out to something much simpler than it looks like it's going to turn into at the start. Any questions on that, friends? All right. I know how you feel about trig. So let's not do trig. But let's do something fun. So how about x squared e to the y cubed plus x plus y equals 7. Find y prime. Put up a rule that you haven't probably seen. Special chain rule for E, you're going to want that. Sorry, Joey. Right here. There's a couple problems. Yeah. So definitely that's good first move, but then plus leave that alone times the derivative of that. And so that's going to be that rule up there. Yeah. Okay. Cool, good. This is being challenged. This is good. Anything I can help with?
Trying to figure
Okay.
it out.
Yeah. So I like your first move. That's beautiful. And that this,
Oh, I didn't put this in.
but you forgot to copy the x squared over here. But otherwise, that's beautiful. But it should have x squared in front of the
Yeah.
second piece.
Yeah.
Yes. Good. Yeah. Yeah, it looks like It just feels like it's gone. Yes, it got, okay, so this is a product rule here, so let's see. You see what I mean? Yeah, yeah, so your instinct is right. How's it going? It looks messy enough to be right, because I know it's not gonna be. Yeah, you rocked it. Okay, how's it going? So let's see, so we did the x, I like that, and then left x squared alone. Oh, okay, I think I had it as y cubed, but that's okay. That's okay, this is perfect. Let's just go with your problem, it doesn't matter. Yeah, that's beautiful. Nice. Nice, and the only thing you left out is that should have a y prime. The second one, because when that guy there, because that was the derivative of y. The second, no, this one right here. So you did derivative of x was 1, derivative of y is 1, agreed, times y prime. Yes.
So I remove this one?
No, that one stays there too, because that one was from this.
Correct.
But when you differentiate that y, we need to also have a y prime there. So there's going to be multiple y primes on the left side. Does that make sense? Yeah. Not quite. So, and we also need a product rule. Can we talk together about this one just real quick? So, you're gonna do the derivative of x squared, 2x, beautiful. The y cubed left one, perfect. Then plus, yeah, x squared left alone times the derivative of the y cubed. Does that make sense?
Yeah.
Yeah. Yes, you are. And then the only thing you left out was you just did that y, so tackle y prime. Yes, fantastic.
I know they're supposed to have a diagram here, I know they're supposed to be.
Yeah,
one.
good.
So if it's the exponent one or this one?
Okay, let's see here, so.
Don't worry about it.
Okay, so that should be a plus, because that's product rule, right? And then, so here, not yet, no, here's the chain rule. When you did this, you took the derivative of e to the y cubed.
Yeah.
You did, this is beautiful, except now times y prime inside there. Exactly. And then this is beautiful. And then that's a y, and then 7, derivative of 7 is times 7.
Oh, yeah.
Dead, yes, there you go.
Yep, perfection. So let me just rewrite that.
Yes. You're getting so famous, things are getting pretty intense here. It looks good. Yeah, this looks so beautiful. This is just that, you're just separating it from your mind, aren't you? I see that. That's beautiful. That's beautiful. Yes.
So when I do the derivative,
Yes.
Yep.
Yep. Yep.
Just,
That's perfect.
Okay.
That is perfection.
Okay.
Yes.
so it's just once.
Yes, ma'am. Yeah, yes, just once, yeah. Product rule on that first piece. That's the derivative of the x squared. Leave the x squared alone. Derivative of e to the y cubed is e to the y cubed times the derivative of the exponent. And I just touched a y thing, so a single y prime plus derivative of x is 1, derivative of y is 1, y prime. So this is one where we've got multiple y primes happening, equals 0. And this is why I came up with that general plan. So keep these two on the left. And in fact, I'm going to rewrite them. I'm going to bring this 3y squared out front. This is just this, and then equals, everything else goes to the right. So that and that. And then factor a y prime out of this side. doesn't change. Divide both sides by this.
Wait, where'd the other y prime go?
I factored it out.
But it's part of a separate term.
Can you
Oh,
elab-
plus what?
So what's confusing you here, Adrian?
Oh! Okay.
See,
I-
you believe
I-
you're with me?
Yeah.
Awesome. Anybody else? I'm happy to talk about any of this. Like, till the cows come.
I didn't realize you could factor the whole thing, I was just factoring the multiply.
Gotcha. Yeah, and quite often what's gonna happen is you're gonna have a bunch of terms over here that each have a y prime on them, and this game is gonna kick in just like this.
Can you explain that? Because when I'm looking at the y prime plus y prime on the upper section, second to last.
Uh-huh. This here?
Yep.
Yeah.
And then you factor out one y prime.
Uh-huh. So look, go backwards. Distributive property, right? This times that.
Oh yeah, I got it.
Okay. It makes more sense going backwards, definitely. In making the forward move, that's the one that we're gonna have to practice here, because it's gonna happen often. Now divide by this chunk. That, my friends, is a beast, but that is your answer. So there are a bunch of these on both the WebWorks, the WebWorks 7, and then the practice stuff, tons of that.
Could we simplify it all?
Say that again?
Could we simplify it all?
Oh gosh, no, I don't think so actually. What were you thinking? I'm just curious.
I'm just looking at, well, there's common terms, I mean, the x squared and the x on top. I was just wondering if that could just be.
So if these weren't here, I would absolutely want to do that.
Okay.
Then nice cancellation, but these really foul things up to make it not possible. Any other questions here?
It was plus one on the bottom, minus
Oh,
one on the
okay,
top.
yeah, thanks. Yeah, I was wondering that even when I did it. I was like, I bet I screwed that up, and I did. Yeah, we good? Or not? Or we can get good. We will get good.
It's a lot of stuff.
It's a lot of stuff. So what I think is bring your laptops on Wednesday. Let's work a lot of these problems. I might start off with one just to, oh no, I'll give you the test. I'll give you the practice test on Wednesday, but bring your laptops so that you can work on web work and all that stuff too. Sound good? Let's call it a day for today. Big day back. That's a big day, period. As Alex said.